June 2026. After decades of science fiction, failed prototypes, and broken promises, the humanoid robot is finally walking out of the laboratory and into the real world. Not into movies, not into research papers, into factories, warehouse, hospitals, and increasingly, public spaces. In California, Tesla is trying to build a robot worker. In Boston, Atlas is learning industrial tasks that once required human dexterity. Across China, dozens of companies are racing to manufacture humanoids at a scale the West can barely match. Investors are pouring billions into the industry. Governments are paying attention. And some of the world's biggest companies are quietly preparing for a future where robots become part of the workforce. But just as excitement reached a fever pitch, the robots started falling. Some collapsed during live demonstrations. Some required hidden human operators. Some injured spectators. And suddenly, the question changed. Not, can humanoid robots walk? But, are we witnessing the birth of a trillion-dollar industry? Or the most expensive hype cycle in human history? Because behind every viral robot video lies a much deeper story. A story about artificial intelligence, manufacturing, economics, geopolitics, and ultimately, the future of human work itself. This is not just a robotic story. This is the story of physical AI. Welcome to the Humanoid Dawn. Before we talk about Tesla, before we talk about China, before we talk about artificial intelligence, we need to answer a surprisingly simple question. Why are we building humanoid robots at all? Seriously, think about it. If the goal is moving heavy objects, a forklift is better. If the goal is assembling parts, a robot arm is faster. If the goal is moving inventory around a warehouse, autonomous warehouse robots already exist. So why spend billions of dollars building machines with 2 legs, 2 arms, 5 fingers, and a human-shaped body? Wouldn't it be easier to build purpose-built machines for every task? The answer is yes. But that's not the point. The point is not about building robots. The challenge is that the world has already been built. And it was built for humans. Every staircase, every ladder, every doorway, every factory workstation, every warehouse shelf, every tool, every vehicle, every control panel, everything assumes one thing: a human body. For thousands of years, humanity has standardized its infrastructure around a single platform. Us, we the humans. Humanoid robots aren't trying to become the most efficient machines. They're trying to become the most compatible machines. Instead of rebuilding the world for robots, we are rebuilding robots for the world. And that distinction changes everything. Because if a robot can truly operate in environments designed for humans, its market is no longer limited to one industry. Suddenly, it can work in manufacturing, logistics, healthcare, retail, construction, hospitality, and eventually, the home. That is why investors are willing to spend billions chasing what still looks, in many ways, like an unfinished technology. Because the prize isn't a robot. The prize is access to every place where humans currently work. And that's potentially one of the largest markets in history. The race is a clash of philosophies. The West focuses on intelligence. China focuses on scale. Tesla's Optimus is the most watched humanoid project. But the journey has been brutal. 2025 production targets were missed. On the Q1 2026 earnings call, Elon Musk admitted production numbers are literally impossible to predict. Tesla has deployed 50 units in Shanghai, but mass production remains elusive. But here's the bigger lesson. Building ChatGPT is primarily a software challenge. Building a humanoid robot is 5 challenges at the same time. Artificial intelligence, mechanical engineering, battery technology, manufacturing, and safety. A chatbot that fails might frustrate a user. A robot that fails can injure someone. The complexity isn't additive. It's multiplicative. And Tesla is learning that reality in real time. Boston Dynamics finally began shipping Atlas to paying clients in 2026. Hyundai has already reserved the entire production run. The focus has shifted from backflips to real work. Figure AI took a different approach. industrial deployment. In May 2026, three-figure 03 robots sorted 250,000 packages over 200 hours with zero hardware failures. BMW is testing them in both the US and Germany. If you want to understand the humanoid race, you need to understand one thing. History shows that the company that scaled won. The company that manufactured cheaper won. The company that reached the market faster won. China understands this better than anyone. Look at solar panels, batteries, consumer electronics, electric vehicles. The pattern is consistent. China builds products that are good enough and dramatically cheaper. The same playbook is emerging in humanoids. China has recorded 7,705 humanoid patents over the past 5 years, 5 times more than the US, and accounts for 54% of global industrial robot installations. Consider Unitree. It shipped over 5,500 humanoid robots in 2025, the most globally. Its R1 robot starts at approximately $4,100. The company recently received IPO approval to raise $616 million. UB Tech began mass production of Walker S2 in November 2025, targeting 10,000 units in 2026. Xiaomi is trialing Cyber1 robots on its EV production line, completing over 90% of assigned work during a 3-hour shift. China's strategy isn't a single champion, it's an ecosystem. Multiple companies, multiple approaches, multiple supply chains, all moving simultaneously. The West is trying to build the intelligent robot. China is trying to build the cheapest robot. History suggests the cheaper often wins once the technology becomes good enough. If 2024 was the year of AI hype, and 2025 was the year of AI products, 2026 may be remembered as the year humanoid robots entered public consciousness. Suddenly, they were everywhere. At CES 2026 in Las Vegas, Boston Dynamics unveiled the product version of Atlas to the world. In Shanghai, at O 2026 in March, Agibots Yuanzing a 2-robot wrote Chinese characters with a brush. The handwriting was imperfect, but it was recognizably Chinese characters. At STK 2026 in Seoul in June, the conversation shifted from locomotion to dexterity. The industry was no longer asking, "Can the robot walk?" The industry was asking, "Can the robot work?" Companies showed robots picking up objects, not just walking across stages. Across Europe, Unitree Humanoids performed balancing exercises and human-robot interaction scenarios. In Istanbul, at Comtech 2026, Zoomlion, the Chinese construction machinery giant, debuted its Z01 humanoid robot performing Tai Chi. The World Intelligence Expo in Tianjin featured a robot threading a needle, a breathtaking demonstration of precision. Automate 2026 in Chicago featured the first-ever humanoid pavilion. Neura Robotics showcased its 4A1 humanoid at CES 2026. The pattern is clear. 2026 is the year humanoid robots stopped being laboratory curiosities and started becoming exhibition headliners. Walking is a demonstration. Working is a business model. But behind all the demonstrations, behind all the exhibitions, behind all the viral videos, a much bigger story was unfolding. Because the real breakthrough wasn't the robots themselves. The real breakthrough was the intelligence powering them. And that's where the story becomes truly interesting. If you watch enough robot videos, you notice something strange. People obsess over the body, legs, hands, hardware. But the real breakthrough isn't in the body. It's in the brain. Traditional robots were programmed, not intelligent. Every action had to be anticipated. That works in controlled environments, but fails in messy reality. A warehouse robot that can't handle a crooked box is useless. The industry's answer is physical AI. Machines that can interpret the world instead of just executing commands. Think about ChatGPT. You type a question. It understands language and generates a response. Now imagine extending that into the physical world. A robot sees a cluttered table and receives a command. Pick up the red bottle without knocking over the blue one. Seems simple, but the robot must identify objects, understand language, interpret intent, predict consequences, plan movement, avoid collisions, control motors, adjust grip strength, maintain balance, and react to unexpected changes, all in real time. Reality is far less forgiving than a chat window. A chatbot can generate a wrong answer. A robot can break something, or someone. The breakthrough is the Vision Language Action (VLA) model. Instead of text in, text out, it becomes vision in, action out. The robot sees, interprets, reasons, acts, and learns. NVIDIA has introduced GR00TN1.6. Tesla is adapting its full self-driving architecture. Google DeepMind is pushing embodied intelligence research. Unitree has built its own VLS systems. Everyone is chasing a general-purpose intelligence that can operate in the physical world. But here's the hard truth. Intelligence is only half the problem. The body matters. A brilliant AI inside weak motors, poor sensors, and unreliable joints is useless. It's like putting a Formula 1 driver inside a bicycle. Tesla discovered this the hard way. The Optimus hand has 22 degrees of freedom, an impressive engineering achievement. But engineers have struggled with reliability. The hardware is impressive. The reliability is not. And then there's the simtorial problem. In simulation, everything is perfect. Objects behave predictably. Sensors are flawless. Reality is different. A cardboard box bends unexpectedly. A floor becomes slippery. Lighting changes. A human walks into the workspace. In simulation, a robot can practice picking up a box 1,000,000 times. In reality, the box bends differently every time. The robot hasn't seen these variations in training. And this is where things fall apart. Sometimes quite spectacularly. As robots become more capable, they become more dangerous. A robot isn't a chatbot. It has mass, momentum, and strength. A Unitree G1 has enough power to cause injury if it loses control. This creates the safety paradox. The more useful a robot becomes, the more important safety becomes. Yet regulations lag far behind. In China, there is no mandatory national safety standard for service robots, only voluntary guidelines. In the US, OSHA has barely begun considering humanoid robots. Courts have no clear precedent on liability. Then there's the question everyone asks. What happens to human work? History shows technology automates tasks, not entire jobs. ATMs didn't eliminate bank tellers. Spreadsheets didn't eliminate accountants. New roles emerge: robot fleet managers, maintenance technicians, supervisors. So where do we stand in 2026? Not at the finish line. Not even close. The demonstrations are impressive. The failures are revealing. The economics are compelling. The safety concerns are real. And the hype is running far ahead of reality. But history teaches us something important. Every industrial revolution looks underwhelming at first. The first automobiles were slower than horses. The first computers were weaker than calculators. Humanoid robots may follow the same path, or become one of the most expensive technological detours in history. Today, nobody knows. For the last 200 years, industrial revolutions replaced human muscle. Humanoid robots may be the first to attempt replacing physical labor itself. The ultimate challenge is no longer technological. It is societal. Can our laws evolve? Can our institutions adapt? Can our workforce transition? Because technology rarely waits for society to catch up. And this time, the technology walks on two legs. The humanoid dawn is here. The question is not whether the sun will rise. The question is whether we are ready for the daylight.